Salem Gold Medal Award. And also his research mainly focus on smart and sustainable agriculture, particularly through the applications of sensors, artificial intelligence, and machine learning and robotics. Through his innovative research, he has developed 11 novel scientific methodologies and 13 advanced engineering technologies aimed at improving the precision agriculture and sustainable crop production. And he has published more than 85 peer-reviewed research papers, hold 6 patents and 4 copyrights, and he has successfully guided 5 MTech and 5 PhD students, with several of his students currently working in leading universities in the USA and Australia. And Dr. Pare has also contributed significantly to the national initiative. He served as the youngest member of Ministry of Agriculture Committee constituted for developing the standard operating procedures for drone use in Indian agriculture. At present, he is serving as the expert member for establishing Center of Excellence for IoT in Agriculture at Akola under the Ministry of Electronics and Information Technology, Government of India. For his recognition of outstanding scientific contributions, he has received numerous awards, including ISTA National Award from 2012 and ISTA Salem Award, and All India Agriculture Science Students Young Scientist Award, and CNH Industrial Appreciations Award and Distinguished Service Award, and Agriculture Today Young Scientist Award from 2023, and IRI Best Young Scientist Award in the last year, and recently conferred H.K. Jain Memorial Young Scientist Award. For these, I would like to welcome you, Prof. Agaman, and you can continue your lecture. Thank you.
Okay, thank you. So should we start the lecture?
Yeah.
Okay. Good morning all who are joining this lecture online. I hope that most of the participants are working in the research and academia who are the part of this training program. So friends, I will be discussing with precision engineering technologies for protected cultivation. I think many lectures had been during the last week, and you have gained the substantial the information on this aspect. So starting with the basics. Is the slide moving?
Yes, sir, it is moving. Actually, we have put the participants on mute.
Okay.
Once the session is over, we will unmute them.
Okay, it's okay. My only concern was that it should be visible to all. So friends, you all know that what is the current scenario of the agriculture production system in the country. We have the adverse weather. On one side, we have the erratic rainfall. On other side, we have the dry land conditions. And because of this weather conditions, on the other side, we have the challenges due to diseases, insects, infestation. And you know that about 40 to 60% of the vegetables in India gets wasted just because of pests and diseases. On the other side, due to the health concerns, increased population, and many other attributes, there is the growing demand for quality food production. And to keeping in view these challenges and the demand for the quality food production, there comes the concept of the protected cultivation. So in protected cultivation, what we do, as you know, that we control different parameters. We control the temperature, humidity, irrigation, and the fertigation, that is the nutrient application. Also, we are able to control, and that is what you see currently the model that is being implemented throughout the country. At least you have these control parameters, that is the humidity, temperature, and the micro irrigation system and the fertigation system. And because of this precise management of these parameters, we are able to grow the high value crop. Now, when we see this high value crop, the question arises of the cultivation practices. Means the crop conditions are okay to grow the crop within the greenhouse, but what about the practices, the human interventions through which we have to go through in the protected cultivation system? You can see what are our existing practices. If you see the spraying, it is blanket application, and because of this, there are many health concerns because a lot of fumes is being taken by the operator. If you go the other management practices, that is whether it is pruning, whether it is harvesting, it's manual, and there is a lot of human discomfort because the crop is at different height than what is the existing height of a worker. So because of that, there is a lot of discomfort. Same way the weeding. So all operations, what is the existing practices, we are not able to precisely manage. We are able to manage the environment conditions, but not the practices. So, because of these issues, we have the human health risk. A single day, if you spray in the greenhouse, it leads to 410 to 560 ml of spray solution, and it is enough to cause the adverse human effects. So it's just when we go for the one spraying application, how much we are receiving. And you know, in the country like India, where we don't have much awareness about using the protection kits, the problem becomes more severe. Same way, when you go for the other operations like picking, pruning, sorting, there are a lot of those operations going in the greenhouse. And if you see on the screen, you see how much discomfort it is for one to have the shoulder flexion because of having something at higher level than our reach level of reach. So because of these musculoskeletal disorders and human health risks, there lies the need to go for the precision agriculture practices in protected cultivation. Why? Because to have the pest disease and weed control, to have the efficient water management, to have the automation of the operations to reduce the human workload, to have the off-season cultivation to prevent the effect of the weather parameters, to lead to the high and better quality yield, and overall leading to high income generation. In the next phase of the slides, I will take you some of the technologies which we have developed here for the protected cultivation, and keeping in view the scientific temper that we have to maintain. I would like to delve deep into the these advanced technologies that currently we see being used expeditiously in different countries. In India also, we are taking such initiatives. So first is the for the spraying purposes, we have developed this site-specific spraying robot for the protected cultivation. Friends, you have seen that when we go in the protected cultivation, if we apply the chemicals through the human intervention, it will lead to the human health risk. So now what we have to do, we can have some automated system to apply these chemicals. But the question arises where to apply the chemical. That's the concept of precision, where to apply, when to apply, how much to apply. So to address this question, we must determine where is the disease present so that we can apply the chemicals only in those target areas. So that has been the objective of this technology, to apply chemicals in only the areas in which there is the disease. But the question arises, if we detect the disease, the detection should be robust. There may be the chances that the external symptoms which we see on the plant, it may be because of the different disease, or there is a chance it may be because of the moisture stress or any other stress. So how precisely we are able to detect that this is the disease, whether it's a bacterial, it's a fungal, that robustness we must ensure. To ensure this robustness, we have implemented the molecular validation technique so that we are precisely knowing that this disease is because of this target microorganism. So we applied the machine learning approach, in which what we did, we took the tomato leaves having the distinct symptoms, and from these symptomatic leaves, we made it the culture to grow under the lab to see what comes out. And we found that diseased samples were because of the fungus. So that fungal to the plant, and when we put to the
Yes, sir. Yes, sir.
Okay. So in this, for the validation of disease, we extracted the pathogen, inoculated, and then recorded the symptoms to have the variation in the samples, to have the healthy, low severity, medium severity, high severity, and we did the sequencing of the whatsoever we have obtained it from the inoculum. We did the sequencing to know whether it precisely matches the causative organism or not. That is alternia isolate, and it revealed 98.6% sequence identity with the alternia that is already available in the accession. So we got that, okay, this is the causative organism, and symptoms are only because of this fungal organism. So then we measured the disease severity in the leaf samples, and to know that if severity is low, we can apply less chemicals. If it is medium, it is high, accordingly we can vary the chemicals. So to apply this, we used the machine learning algorithm to determine different stages. And in this, what we do, we first go for the image pre-processing, in which we make the images to a particular size. Then you may be having less data set. Let's suppose you have very less data set. So we have to enhance, add the number of those imaging data set. We go for the image augmentation. We go for the rotation of that. It is simple like that. If we show to the child a mobile phone in one direction, maybe there may be miscalculation. But same mobile phone, if we rotate sometimes, if we flip it sometimes, then he will be having the better training. Okay, this is mobile phone and this is different than the other. So we use the image augmentation like rotation, flipping, sharing, zooming.
Hello.
Results, but what actually we get this you can see that we use the Google Colab platform. If you put in the Google Google Colab, you will get it, and you can run the imaging data set. So this is for the severity. We found that mobile net is the best model. If we from the imaging data set, we have to get the disease severity we can get. So it gives the results like this way, that this is high severity, this is low severity, this is medium severity. And for detecting where is the disease, if you can see on the screen, on the real time in the greenhouse, we are able to detect whether this portion is diseased or whether this portion is healthy. Is it visible on your screen? You can see it is a moving camera within the greenhouse, within the protected cultivation, to determine where is the disease. And if you know where is the disease, you can apply chemical only in those diseased areas. That is the beauty of the technology, that integrating the objective detection model with the target spray application. So it's under real time conditions we come to know where is the disease and where is the healthy part using the YOLO model. And based upon this YOLO model, we developed the sprayer that has the camera that detects where is the disease region and applies chemical only in those areas. So I will show you directly the technology which we have developed. This is the machine vision based site specific spraying robot. Friends, this is the level of precision when we start from blanket application to second stage is detecting the canopy. The third stage is going deeper into that and detecting where is the disease. So this is the best precision technology in terms of that we are trying to save the chemicals by applying chemicals in only diseased areas. So this is the spraying robot that has the scanning system. It has the linear scanning camera, um, through which it detects where is the disease. But before developing this, one of the that we don't have much space between the rows, so that there should be the zero turning. The turning should be in the minimum possible. If you see on the screen, on the target spray application technology for the protected cultivation by detecting the early blight disease. Now, if we train the model for other disease, we can integrate with this sprayer and make it happen to have the target application for other diseases. If you see what is the advantage of developing such technologies, when we go for the conventional application, we go for blanket application. On an average, we can save up to 70-75% chemicals. And if you see the cost economics, friends, the thing is we can develop very advanced technologies. But the question remains, who is our stakeholder? It's the farmers of India who are 80 to 85% falling in the category of small and marginal. So technology must be affordable, accessible, and appropriate. These are the three concepts we have to use whenever we develop any technology, so that keeping in view that it serves the purpose of the farmers of this country. So taking all those factors into view, this technology we are able to make in a cost of 1,60,000. And if you go for the one application, you can save 70-75% chemicals. And if you see the application rate in the developed sprayer and the battery operated, that knapsack sprayer, you will see the significant difference. Not only this, the penetration and other this, yes, there is one bigger challenge in the robotic technologies, that's the speed. We have to make such systems operate at very low speed. So it's because of the point that the hardware system, processing system available in the country, we is of the value that where we need a lot of processing time. So if processing time is more, we are not able to make the technology to move faster within the greenhouses. Otherwise, there will be a missing percentages in terms of disease regions. The second is that these days we see that there is a lot of fluctuations in the market, where we want to harvest the product at different maturity stages. Let's suppose that somebody wants to use the tomato for the pickle. They may be in the different level of maturity compared to those who want to use it in the household for the cooking purposes. So if we are able to go for the selective harvesting, let's suppose I want to harvest only the ripe tomatoes, or I want to harvest the tomatoes at the semi-ripe conditions. For that, this is the technology we have developed. In this, again, first we try to have the detection. Where is whether it is ripe, it's semi-ripe, whether it is unripe. So for that, we implemented the YOLO model to check whether we are able to detect this maturity of the tomatoes properly or not. That's the first stage. Then the second stage remains integration with the technology. These days, there is a lot of these fancy words in the market: AI, ML, robotics, IoT. All those things are there, but the point is that we have to make them as simple as possible. So the first thing is, what is more important is the basic sciences, whether it is a disease detection, whether it is any maturity detection. The second part is that integration with the technology, so that there is proper synchronization. So in this also, we did the first part, that is detecting the maturity of the tomatoes. Then in the second stage, we try to see whether it can be integrated properly with the technology or not, so that we can have the selective harvesting of the tomatoes. So it is the efficient autonomous robotic tomato harvester. You can see how it works in the greenhouse. We try to have the initial trial whether it is able to detect properly the tomatoes or not. The evaluation time was when the tomatoes were not available. So we have to create just for experiment purpose whether it is able to detect or not, and it is precisely able to locate the tomato or not. So now only we need to change the robotic arm, and then we can have the complete system integrated with maturity detection. So this is how it detects the tomatoes in the greenhouse and of particular maturity, and then allows the selective harvesting of the tomatoes. Coming to the third is that the virus is one of the most damaging this disease causative in the greenhouse if it is carried by any vector. And once the disease virus gets infected in the plant, then there is the very rapid expansion of this disease. So, is it possible to have the early detection that this plant will be now getting affected by the virus? For that, we have developed this handheld device for the GBNV virus, that is groundnut bud necrosis virus, that mostly is affecting the tomato crop and cowpea. But we have developed it for the tomatoes for the greenhouse. We can, with a simple system, we can come to know whether the disease is virus is going to infect this plant or not. Means the early symptoms, like we have during the COVID time, we used to see just by the infrared thermometer that there is a chance of that the temperature is building up, and we are supposed to get infected by the virus before the actual symptoms arise. So this has been the same purpose. So for this, we inoculated virus to the plant, generated the data set, determined the spectral in the wavelength of 350 to 1000 nanometer, and then based upon that, we developed this device. It's a simple handheld device which gives us the information about whether the plant is to be getting infected with the virus or not, GBNV virus, and it has the accuracy of 93%. And it gives the classification that is in the range of whether if it's already infected, then what is the severity level, 11 to 25%. It at least saves 2 to 3 days, and there may be some plant pathologists. Now plant pathologists are using it for a scoring purpose, that what is the viral load by knowing the severity. So this is for the severity detection. uh, then, friends, at the very early, I started that the challenges we have the greenhouse is that pruning, harvesting, those are a lot of challenges there. So for that, this is a very simple, the hydraulic operated variable height platform, in which by simple having a paddle, we can increase the height, we can reduce the height, depending upon who is the operator and at what height he has to carry the operation. If you see my earlier slide, in which there was a lot of discomfort where we have to take very high this shoulder angle, and there will be a lot of discomfort to the neck. But when you are operating at proper height using the variable height platform, the discomfort is reduced. So in this, it's a hydraulically operated. There is a paddle that allows to make the hydraulic lift of 60 centimeter. Gradually, we can control at particular height within this range, and then based upon this, we are able to carry different operations in the greenhouse without much discomfort. This is for the pruning, and then one more is that, friends, we have the challenge in the greenhouse. I told you earlier, we're controlling many parameters. We are controlling the temperature, humidity, the nutrient application, the irrigation, but there are also some challenges. If you see in the greenhouses, the pollination is a challenge. Why it's a challenge? The two, three reasons is, one is that the pollination depends upon the humidity and temperature also. If humidity is, for example, very high, then it's very difficult for pollen to move from its existing state to the make it to reach the target point. Same way, there are not these bees who can help in the pollination. For example, if you see in tomato, this is one challenge because of the self-pollination. So this has been developed keeping in view to increase the pollination and overall fruiting yield in the greenhouse. So it creates the, it's a simple blower, but at what pulsations, what is should be the frequency so that the optimum pollination takes place. It should not damage the crop. It should simply make the pollen to move. So this is, if you see on your left side of the screen, it has the pollinating unit that's pulsating. It goes up and below 15 degree, and at the back end it is being blown through the blower, and we can have the movement of the crop and the transfer of the pollen. Because of this, we are able to increase the pollination efficiency. So we can increase the pollination efficiency. Normally people use, some places people use blowers, but the problem with the blowers is that is not scientifically matching the what should be the frequency of that operation, so that it's not affecting the crop, it's only increasing the pollination. So that is what this leads to around 83% pollination efficiency. And what should be the airflow rate? Those are the design parameters we have to take into consideration when we design such things. Then the last one, I hope that whenever we go to the greenhouse, we have to carry the different operations. You might have gone across this also earlier. I hope my colleague Dr. Dilip might have discussed it. In this, we are able to carry two, three these operations simultaneously. Means we need not to go every time to bring for making the beds or for spraying or for these pollination. So we can keep one single in a greenhouse, and whenever any of these three operations is required, we can go for this. So this is the electric multi-tool carrier for protected cultivation. It's a battery operated, so we can go for the bed making, we can go for the spraying, and we can also go where I showed you earlier, that is the pollination pulsating this equipment. That is at the back end. If you can see at the two sides, same way, if you see the bottom side, it's a bed format. And if you see the front side, right and left, you can see it is the for the spraying purposes. So a very simple technology that can be used to mechanize three different operations in a greenhouse. It's like an integrated system. So yeah, you can see that we can have these all three operations. Whether you want to increase this pollination, you want to spray, you want to make the bed, you can do it. Friends, these are the very means uh, useful technologies, and in the earlier which I discussed, they are advanced, but we have tried to keep them reasonable for the Indian conditions, because we can make as advanced as we want, as complex as we want, but the thing is that adaptability will be a challenge. Who will use them? Who will repair them? Those challenges will be there. So we have to make the different combo of technology so that that suits the Indian conditions. So the first one, I try to keep the PPT very short so that I can take the questions. That is the major way of learning. I can learn from you and you can learn from me. That's why I try to discuss these five, six technologies that are very useful for protected cultivation. And here I would like to end my this talk with the conclusion that in India, technology must bend towards the farmer, not the farmer towards the technology. If AI cannot speak the farmer's language, it cannot serve the farmer. And these days we know that the engineers must know the biology, biologists must know the engineering. It's a multidisciplinary approach. Whenever we take any problem, we need not to work in silos, and discipline is specific. We have to extend our capability in different areas, learn, and then implement. So we have to work in that environment. And the last and the most important, you have seen these days a lot of startups, lot of innovation, a lot of things going on. But the reality comes when you go to the field. Any innovation must survive dust, heat, and reality, not just the closed door presentations. A developed nation cannot be built on distressed farmers. When intelligence reaches the field, prosperity follows. And you all are there. We can collaborate, we can work together, because that is the main purpose of joining and discussing. It's a beginning, and we can keep together and make it a progress and working together towards the success. Thank you all.
Thank you. Now the session is open for the question answer. Please ask. If you have any queries or doubts, please clear.
Any question, any query? Otherwise, I will have a question for you. If you don't ask, then I have to ask. Because I want to learn. Feel free.
Thank you, sir. Nice presentation.
That's okay. But my only point is that I will be happy to take some questions so that will give me opportunity to learn if I don't know. If I will be happy if somebody can put some questions so that give me a chance to learn.
Any questions?
If let us suppose, friends, I can see that there are around 80 participants. Anyone interested in working, whether a biologist or anyone, pathologist, anyone who among is interested to work in this advanced areas of precision, robotics, machine learning, AI, IoT, or technology development, and if you are facing any challenge, you can discuss. You don't have question, it's okay, but always use such platforms to learn. I thought that I will learn today from you, but there is no question. That's a mm, problem. We simply digest what is being talked about without having any inquisitive mind to ask